This is chapter 2.1, exercises 33 through 38. In this section of the book, we're working with polynomial functions, and in this case, quadratic functions. And so in this exercise set, exercise 33 through 38, use completing the square to describe the graph of each function to support your answers graphically. So after describing using completing the square, we're going to support our answers graphically by graphing in a calculator, seeing what it looks like. So we have f of x equals x squared minus 4x plus 6. And so what we're doing is trying to create a perfect square, and the main determinant of that is going to be what this linear or x term is. So let's just rewrite this. F of x equals x squared minus 4x. And then we're going to add something to complete the square, and we don't know what yet. And whatever we add, we're going to have to subtract to have a net zero difference. Now, I've seen this handled another way. I've seen this handled by subtracting the 6, moving it over to the other side of the equal sign. But we just have to remember that whatever we add, we need to subtract the same thing. And to find out what to add, we take this middle linear term, our coefficient, which is negative 4. And we divide that linear coefficient by 2. And we get negative 2. And so if we square, so I'll just say we square half of the linear coefficient. Or let me just say it differently. I'll say the of the coefficient of the linear term. And so that tells us what we're going to have to add. So we take this negative 2, square that negative 2, and we get 4. Meaning, now we're going to have to add 4 to complete the perfect square, and to have a net no difference on the right side of this function or equation, we need to also subtract 4. So this whole thing I'm now wrapping in red parentheses here is what is our perfect square. So now what we have left is f of x equals, we rewrite this x squared minus 4x plus 4 as quantity x minus 2 squared. And then what we have left is we have minus 4 plus 6. Well, minus 4 plus 6 simplifies to 2. So this is going to be our equation. So it says we describe the graph of each equation. And what we have is we have a graph we have vertex at, we have x equals 2, x minus h, so we're going to have positive there, positive 2, and then up 2, and since a is positive, we're opening upward, and axis of symmetry we have x equals 2. So we have our function, we have our vertex, our axis of symmetry, and parabola opens upward. And since we're opening upward and our vertex is above the x-axis, we are not going to touch the x-axis. So we're not going to have any real zeros. And to verify graphically, we go to our calculator, and so there's the function, and we graph it, and we see the vertex at 2, 2 and opening upward. So that pretty much takes care of that problem. We go back and just box in everything. We have our function here. We have our vertex at 0.2, 2. We have our axis symmetry, x equals 2, and parabola opens upward. One thing I didn't mention is we have a y-intercept at 6, which we see from the original function. So parabola opens upward, and that will take care of that one. Now let's go on to problem 35. Here we have f of x equals 10 minus 16 x minus x squared. So let's rewrite this first of all in standard form, which is going to be negative x squared minus 16x plus 10. And what I want to do for this is have just x with the negative outside. So I'm going to rewrite this as f of x equals negative, and I'm going to put x squared minus, I'll say plus 16x. And then I'm going to leave outside that, I'm going to put this plus 10 right over here. And now, what we're going to do is I'm going to leave a gap for our completion of the square equals negative, I'm going to say x squared plus 16x, and I'm going to have plus over here and leave this gap to fill in here. And then this number is going to be negative here because whatever number goes in here is going to have to be offset by a negative. So we'll say minus, open parentheses, plus 10. So whatever we put in parentheses is going to have to go both inside here, perfect square, and outside. Again, we have the linear coefficient as 16, and we divide that by 2, and we get 8. So the number we need for completing the square is going to be 8 squared, which is 64. And so we're going to fill in here 64 and take 64 outside here. And now we're going to just complete that square. And to do that, well, we have the square completed. We're just going to rewrite it like this. F of x is equal to negative. We're going to have x plus 8 quantity squared. And then we're going to have minus 64 plus 10. So minus 64 plus 10 is going to be minus 54. Okay, let's see if we did that right. No, we didn't, because we subtracted 64. We're going to have to add 64 over here. Okay, caught that mistake. And so when we do that, we're going to get plus 74. Got to watch out because we We took the negative sign times the 64, which means we had to add back over to the right of that. So this is going to be our function, and the axis symmetry is going to be x equals, now we'd have minus negative, so for this we'd have to have our axis symmetry at x equals negative 8. So we'll say axis symmetry is going to be x equals negative 8, and our vertex is going to be the coordinate pair negative 8, comma 74. Now, we know we're going to have a downward opening parabola since we have this a outside negative, so we'll say downward opening parabola. And we know since we're starting up above the x-axis and we're downward opening, we're going to have some real roots. And so for that, we're going to have what the value is going to be. X is going to be equal to negative b plus or minus the square root of b squared minus 4ac, and you see I left parentheses, over 2a. So we just fill in what we have here. Well, a is equal to negative 1, b is equal to negative 16, and c is equal to 10. So we just start filling in. We have a negative 16 plus or minus, we have negative 16 squared, 4ac, well a is negative 1 and c is 10, and then over negative 1. So what we have here is we have negative 16, or it's going to be positive 16, x equals 16 plus or minus, we're going to have negative 16 squared. Now that's going to be, I don't exactly recall what that is right now, so 36, okay, 9, 16, so we're going to have 256. I should have known that, okay? The square root of 256 minus 4 times 1. Well, that's negative times a negative, so we'd say plus 40. And we're going to have over negative 2. So that's going to be 16 plus or minus square root of 296 over negative 2. And what we're going to have is we're going to be able to take 4 out of that. So we take 296 divided by 4, we get 7 times 4 is 28, 1, 6, so 74. So we're going to have x equals 16 plus or minus we're going to have, I'll just write it like this, 4 times 74 over negative 2. And what that's going to simplify to, we take this 4 out of the radical, we're going to have 16 divided by negative 2, which is negative 8, plus or minus, we're just going to have left 2 over negative 2, so it's going to be plus or minus square root of 74. So these will be our x-intercepts. Okay, x-intercepts, negative 8 plus or minus square root of 74. So that's a little tedious. Next, now we're just going to graph this, see what it looks like. Go to our calculator, Control I. Control I, and graph. Up here, this function 2, that's it. And we can't see it very well, so we're going to have to adjust the window. And adjust the window, menu, window, and window settings. We're going to go to negative 20, comma 8. So negative 20, 8, tab down, and our y values we're going to have are negative 100, comma 100, and tab down here, and this is what we get, a graphical verification. We had negative 8 as our axis of symmetry, plus or minus square root of 74. Well, square root of 74 is going to be a little bit bigger than 8, so between 0 and 1 is one of the x-intercepts. And over here on the other side, between negative 18 and negative, let's see, it's negative 19, 18, negative 17, negative 16. Okay, let's go on to the last one we're working at. We have f of x equals 2x squared plus 6x plus 7. What we're going to do for that, it's already written in standard form. We're going to have 2, write this f of x equals 2 times, we'll have x squared plus 3x, okay, plus 7. Put plus 7 on the right. So we're going to have to add to this to make it a perfect square. So I'm going to put plus parentheses, and we're going to be subtracting on the other side. And to find out what that needs to be, we take 3 divided by 2. That's going to be equal to 1.5, and we square that. We're going to get 9/4. So 9/4 is what we're going to need to add. So just doing that, I'm going to say plus 9/4. Now we added 9/4 here. We're going to have to subtract. Now remember, it's really 18/4 because it's going to be distributed by 2. So over here we're going to have to subtract 18 over 4. Okay, I hope that makes sense. And when we do that, we're going to have f of x, writing this as a perfect square, it's going to be 2. We're going to have x squared, and it's going to be plus this value of 3/2. we square that. And then we're going to have minus 18/4 plus 7. Well, 7, it's going to be how many fourths? I think that's 28/4. So we have minus 18/4 plus 28/4. And that's going to be f of x is equal to 2 times quantity x. I made a little misstep here. It's not x squared there, it's in parentheses x. Okay, good, fix that. And so we're going to have x plus 20x plus 3/2 squared, and we're going to have minus 18/4 plus 28/4. Well, negative, that's going to be 10/4. Which is going to simplify to 5/2. So we're just going to add 5/2 here. So this will be our function here in vertex form. Our axis of symmetry is going to be x equals negative 3/2, and our vertex is going to be the point negative 3/2, comma 5/2. And we're above the x-axis and we're opening upward, so we will say parabola opens upward. And what else? We have this A2, and is vertically stretched. By a factor of 2. And the last thing we're going to look at is, I'm going to try to verify all this. I'm going to box it in first just to get that out of the way. So we go to Control I, add graph. I'm going to look at this last graph here. And here we have it's really hard to see fractionally, but we have this parabola. Our axis of symmetry is going to be x equals negative 3/2, and we can verify that in the calculator menu. Analyze graph 6. We're going to look at a minimum. Go to the left side, go to the right side. We have negative 1.5 for x value, that's negative 3/2, and 2.5 for the y value, which is 5/2. So that all checks out. So we've done all these odd number problems. Here's problem 38, the last even number problem. Good luck on your remaining exercise here. And as usual, I say thanks for viewing.